not art sketching. One line only, is that clear? Do you know what I'm talking about?
Yep.
No going like this, it's like one through line, okay? Multi-view drawings, you know, and multi-view drawings is more than one view, and it's a set of orthographic drawings. And the standard format is to have the front, the right side, and the top view. And then an orthographic view is when you're viewing the front horizontal or profile plane perpendicular with your eye. Today we're looking at pictorials, so I'm just going to save this. Again, with, you know, when you have an isometric, this is always the front, this is the right side, this is the top, okay? Because standard is always front, right side. If you pick this as the front, then this is the left side, and that's not the way it's standard in the US. Front, right side, top, okay?
But
Yeah.
when you draw now, let's say you need to, let's say you're drawing the 3D view.
Yes.
You have to have the one with the most features in the front.
Gotcha, hang on. Let's, let me show you this for a minute. So if you have an object and you are the design engineer, you get to choose what's the front, what's the top, what's the right side. So on a stapler, I probably would choose this as the front. I probably would choose that as the right side, and I'd probably choose that as the top. Why would I choose this as the right? And not, why not this? There's more information over here. But, so as a design engineer, if you're just given a part, you get to decide what's the front, the top, and the right side. What we're looking at right now is when I give you an isometric, the design engineer has already decided that this is front, this is right side, and this is top, and you have to draw it accordingly. Front, right side, top. Okay? Or, if you're given 3 views, which is part of the homework we're going to be working on today, if you're given 3 views, what's this? Front, what's this? Top, what's this?
Profile.
The right side view of the profile. So when you draw your isometric, you have to draw this from the left side, this from the right side. Does that make sense? If you're designing the part and you're given a part and there are no drawings, you get to choose what's front, right, and top. But if you're already given the multi-views or you're already given the isometrics or the pictorial, it's already been determined for you. You have to follow what they do, what they're giving you. Does that make sense? Okay. Did that answer your question, whoever it was? I forgot who asked.
Yeah, but
Okay, Edwin. Land before time.
What does that have to do with engineering?
I think he's trying to irritate.
Oh.
Okay, I must have pressed save. Okay, I'm back to modules. Okay, now on drawing rules, lettering and height rules. Now, lettering, you know, the term lettering doesn't just mean writing letters, right? It also means writing numbers. Lettering is the act of clearly writing numbers and letters for engineering drawings. So if I go here and I know, you know, we already saw the sheet. Let's look at the second sheet here. So now I know that when you put your name on a piece of paper, we talked about A, B, and C size? Actually, I think I only mentioned it with that first group when we rotated. So we gotta do that. Barbara, could you turn the light on? I have lights on. Okay, A size drawing is this. So it's 8. Be efficient, grab here. So 8.5 by 11 is an A size paper. Okay? B size paper is double A size. So if I take two sheets, and it's one sheet, this is a B size paper. And accountants would call it ledger paper. Have you ever heard that word, ledger? So this is B size. So B size is what? It's still 11, but it's by 17. What do you think C size is?
22 by 16.
Right, 4 times A size, I just double the B. Flip the B over. So now I have, here's my B, and now I make my C. So my C is 17 by 22. And then D size is what?
It's a big
Right, double C, so it's 22 by 34. So it's almost 2 feet by 3 feet. Okay? So all the drawings we've been doing so far are on what type of paper? A size, right? And when you write your name in the bottom or on the side, that's really the title block. So for a title block, and you know what section letters are, right? Cutting plane. Title blocks for all paper, it's 1/4 inch high. So whenever you write your name on the paper, it should be 1/4 inch. Okay? If you're dimensioning, notes, tables, letters, lines, title block numbers, for A size it's 1/4 inch, but basically this is the ANSI standards. The ANSI standards for heights of letters and numbers on different size paper. Okay? I'm going back. Where was I? I was under rules. So terminology we looked at, drawing rules. This is the lettering and height rules. The line type, and this page was also under lettering when we did it in class 1. Line types are here, and you just reviewed them. You reviewed them for all those ANSI standards of line types, and those rules are under, I guess, class 3's notes as well. So they're also here, right here. So students in last semester's class asked for me to put all the rules here too. The next rules we're going to see is scales, but we're not going to do it for a while, and then dimensioning is the last topic we cover in manual drafting. Okay? And then I'm going to close the different classes, and today we're in class 4. Okay. So today's topic is 3D sketching, and we're dealing with isometrics. Actually, I'm going to go back to terminology, because I want to show you this. Nonce. Okay, so the word to describe 3D, the word to describe 3D drawings is called pictorial, or pictorial, okay? I learned it when I was in New York, because that's where I first went to school, and I was first an engineer, and we just called it pictorials, but you know, New Yorkers don't always pronounce everything right. So I probably should find out how it's pronounced. Maybe, Robert, have you seen that word pictorial? 3D drawings?
No.
Is it pronounced pictorial or pictorial? I'll look it up.
Yeah.
Okay, there are 2 different types of pictorials, you already know, isometrics and obliques, right? And obliques, you know, is you see the front face and its true size, and then you see the top and the right side off at a 45-degree angle. And isometrics, which are actually seeing everything true size, it's where it's off at a 30-degree angle. So, and there are 2 different types of obliques. One is cabinet and cavalier, and we're going to deal with that on Monday. That's the topic for Monday. So right now we're going to just be dealing with, let's go, with isometrics. So I just gave everybody paper. This is paper that is on class 1, and when you want to draw isometrics, if you want to use this paper, then print out a bunch. I just printed out I print out one for everybody just for the hell of printing it out today. Just like I gave out the engineering, 1 sheet of engineering paper on Monday. But you could use engineering paper to do it. In fact, I would just estimate, where's a sheet of engineering paper? Where's a sheet of engineering paper? Yes, that's okay. Yeah, Robert, would you pass one up? So What are isometrics drawn at an angle of? 30 degrees, right? Isometrics, draw. So here's your horizontal line. And then you go up 30 degrees, and go up 30 degrees. And what's here? What's on this side?
Front view?
Front view. And then here's my profile, and then my horizontal. So I'm going up 30 degrees. We can estimate. In this case, if you're using engineering paper, you just go up one box and over 3. 3 to 1, 3 to 1, 3 to 1. That's really 33 1/3%, but it's close enough for this class for 30%. 33s rather. Wait. Yeah. No.
I think you can do 3 by 4.
Yeah, you know what I'm doing? I'm doing a ratio. I'm doing a 1 to 3. I'm not doing 30 degrees. So 30 degrees correlates to, it's scaled. What is it?
203 is a 36.
If I go over, so it's the, I don't wanna do
that's 30
angle.
degrees.
I wanna do grade. So it's the change in vertical of the change in horizontal times 100. And that's percent, but I don't want percent, I want degrees.
So you're
So
gonna
we're
have
gonna
two on the
use
bottom.
tangent.
So you gotta have 2 on the bottom and 1
Wait,
on the
tangent
side.
of L is equal to, what is this on the bottom?
1.
If I got, what's the tangent of 30 degrees is what? Somebody do it on a calculator? I see all those calculators coming out of your bags right now.
Oh, I hear one over 2 or something.
Come on, you guys, this must be a loaded calculator.
0.57735.
Say it again?
0.57735. You want me to say it one more?
This one is 0.57735?
That's tangent of 30 degrees.
Oh, thank you. Okay, so then if we have, it's equal to the rise of the run, so it's y over x, 0.5. So it's gonna be almost 1 to 2. Anyway, you could figure it out, but
So
use the boxes.
You can let x equals 2 and y equals 1.
Y equals,
1,
and x equals,
2.
yeah, well, it's close,
It's
right?
30, 60 degree.
I think it's 1 in root 2.
It's a little bit, yeah.
100.
Try that.
3.
What's 1 over root 2? You think it's 1 over root 3?
Yeah.
You like getting into the math part of engineering? What's 1 over root 2?
0.707.
Okay, so then what's 1 over root 3?
Points, 1 over root 2 is 0.7.
Okay, so
Yeah.
what's 1 over root 3?
It's
577.
Great. Okay, so y, so if this is 1, this is root 3, and root 3 is? What's root 3?
0.57.
Oh, right, we already know that one.
Or no, wait, root 3.
No, no, you're right.
It's 1.73 ...
1 point?
73.
So we can make this 3. No, that would be 3.5. Anyway, do you know what I'm doing? I'm trying to figure out how many boxes to go over to get 30 degrees. Measure, you know what? Use the protractor.
This triangle is a 30, 60, 90 triangle, which has a size of 1.
Ah, yeah, and you have the 30, 60, 90 triangle.
It's a 1.
Okay. In any event, if you want to use engineering paper, you can. But you can also use the isometric paper. Okay,
Yeah, basically, if you're just trying to say that you can go up 1.
so now the exercises that we're doing today are these 3. these 3 pages. So pull out your packet. You have 4 sheets. Starts with this. That's number 1. This is sheet number 2. Sheet number 3. And sheet number 4. So these are the sheets that you're going to be drawing on. And the grid lines are there for an isometric. So what I'd like to do is just show you a couple of different ways to approach drawing the isometrics. It's 5 over and 3 up is 30 degrees. 5 over and 3 up. Okay. All right, so let's go look at the 3D drawing. So I showed you this on Monday. This is an object where we're looking at, we only need to draw 2 views because it's symmetric. And this is my front and this is my top view, and I'm able to produce this. Notice, right, is this drawn correctly? I have this piece right here, this orthographic view, is being shown on this side. Is this correct? Yes, because the isometric has to show the front coming from the left side. Don't make that mistake. Always make sure that you're doing that. Okay, so let's take a look at this. If you're given 3 views, how do you approach drawing a 3-dimensional drawing? So this is oblique, and this is an isometric. The way I typically approach it is I first look at my 3 drawings and see where the material is missing. There's missing material here, and there's missing material here. So when I look at the front view, I know that this right here is missing material. And when I look at it from the top, I know this is missing. So that's typically how I start. This is the end result of the drawing. And I do actually always draw the full cube first. So I draw a full cube first. And we're doing isometrics today. On Monday we'll start doing obliques. But I start with my full cube and then I start removing material. And again, I do it in the same manner I would do it if I was cutting away the material from Play-Doh. So let's look at an example here. So this is the object that they're trying to draw. First thing you do, so first step would be draw a horizontal line. Next step would be draw these 2, the width line and the depth line at 30 degrees up. And then I would look at the total width of this object and the total depth of this object and put a little marker out here. So this is my total width, this is my total depth, and then I transfer the parallel lines up, and in the end I have my cube. Then from my cube I see, oh, this piece right here, this corner is cut off, and this whole front part is cut off. So what I would do is I would draw it so that it has that piece cut off, and then I would cut this off, and I would cut this off. That's the way I approach it. I approach it as me taking material off, like how a machinist would do. They would start with a hunk of metal, and then they would cut away the material until they get the part. And that's how I always approach it. This is an oblique. But what I also want to show you is that in this module, I went through YouTube and I found some videos that showed drawing isometrics in a different way than just the removal of material. So I have 3 videos on here if you want to pull them up or watch them up here. And then of course there's the reading on this, and then the homework, which you have the homework sheets already. And I have some extra, once you finish the homework, those 4 drawings, if you feel like you need more practice, then go to these extra isometric examples, and here are, the solutions are in here and in here. Okay? All right, let's turn the light on. Do you wanna watch some of the videos, or do you wanna just get started? Do some of you wanna watch the videos? I could just turn them on,
Yeah.
and if you wanna start drawing, you can start drawing. Okay, so let's shut the lights. And those of you who wanna just start drawing, but let's watch, but I'll turn the videos on.
Thank you.
Okay?